Let's talk about Boolean functions. So the definitions for a Boolean function, they're pretty technical and hard to read. And you can go ahead and read a definition in the textbook, or you can Google it online and find a definition for a Boolean function. But let me just kind of explain it in really general, simple terms. So a Boolean function has some number of input variables. So it could be a function that is just x with a single variable, or it could have two, like an x and a y, or three, x, y, and z, or more. So it's some number of input variables, and each of those input variables can have the value 0 or 1. What a Boolean function does is it identifies a result, either a 0 or 1, for all combination of the input values. So that's what a Boolean function does. It takes some number of input variables, and then it identifies what is the result for every combination of those input values. So the output, it's really telling you the output. Now there's several ways that you can express a Boolean function. Two of them are with an input-output table, and this is commonly also referred to as a truth table, or it can be expressed with a Boolean expression. Here's an example. On the left, we're seeing a Boolean function expressed as a Boolean expression, x times y. On the right, we're seeing a Boolean function expressed as a table, an input-output table, or a truth table. Now let's look at this. This particular table looks very similar to the AND truth table, or conjunction, that we've used in the past. Now, there are some things where they're alike and some things where they're different, and I want to let's talk about that so that we don't get confused by them. Notice that when we're using Boolean expressions, or Boolean functions, when we're using Boolean expressions, we're using zeros and ones. So you see the input values x and y have values of 0 and 1. When we were working with the logical AND operation, we were using true and false. So that's one of the differences. But the result of multiplying x and y and doing AND with p and q, the results are the same. But when you look at the order, it's very different, right? Because the falses are zeros and the ones are trues. And what we see here is we start with the zeros with the input-output table, and we start with the trues on the other truth table. So they're in a different order. Another thing that we see is how it's labeled. So for the function, it's really the final output is just labeled as a function, f of x and y is how that's labeled. Whereas in the truth table, it's labeled with the actual logical expression, P conjunction Q. So the label of the final column is different, and zeros and ones compared to T and F's, and then the order of the tables themselves is how they're different. Here's another function on the left, again, expressed as a Boolean expression, x plus y, and on the right, that same function is expressed in a table. Again, how are they like? How are they different? This is the, x plus y is very similar to p disjunction q. Oh, that's wrong. So that's a disjunction. I'll fix that before I post that. But the disjunction or operation. So similar in the results, different in the order, and different in the labeling. Here's another one that isn't one of our basic default ones. So this is a function on the left. It's expressed as the complement of x times y, and on the right, the Boolean function is expressed as a table.